Greetings to you all, welcome back to my channel. So we are continuing from where we stopped in the last video. So we are continuing from question 9. We stopped at the 8th question under sets. So question 9. Question 9 is saying that A is a set, list all subsets of B, subsets B of A. So the subset is B of A, such that the 1, 2 is what? A subset of what? B. So B of A, I believe you can all list the subsets, so there's no need for me to list it. It's either you list it one by one. So 1 is a subset. Don't forget about the empty set. The empty set is also a subset. 2 is a subset. So in that order, 3 is a subset, 4 is a subset, 1, 2 is a subset, 1, 3 is a subset, 1, 4 is a subset, 1, 2, 3 is a subset, 1, 3, 4 is a subset, 1, 2, 3, 4 is a subset, 2, 3 is a subset, 2, 4 is a subset. In that order, so the subsets are plenty. So B of A is a large set because the subsets are plenty. Okay, so but here our focus is on only the subset that contains 1 and 2. So B should be what? So our B should be either 1, 2 or 1, 2, 3 or 1, 2, 4, and the last one is either 1, 2, 3, 4. Oh, sorry. So this. So the subset. So here, let me cancel this. Okay. So here the members are what? B should be equal to 1, 2, 1, 3, 1, 3, 4. Sorry, 1, 2, 4, and then what? 1, 2, 3, 4. So it has 4 members. 1, 2, 3, 4. So these are the subsets of what? B. These are the subsets of A. So these are B of A members. This is B of A members, where 1, 2 is what? Is contained in what? B, or where 1, 2 is a what? A subset of B. So let's look at the second question. So you can apply the same throughout. Here is just the other way around. So the next one, B. So we have A now. So our A, we know that A is now equal to what? So A, so B should be in A, B should be what? Equal to 1, 2, what we've listed up to what the last one, the fourth one, 1, 2, 3, 4. So it has 4 members, 1, then the other 2, and then this. Okay. Okay, so B is contained in 1, 2. So B is such that it is contained here, meaning B can be found in what? 1, 2. So let's list the values of. So if you want, you can just list the subsets of this. The subsets of this are what? This. So they want the subsets of what? 1, 2. This and 1 itself, 2 itself, then 1, 2 itself. It also has what? How many members? 1, 2, 3, 4. The null set is a subset of all sets. So the null set is also what? So it also has how many members? 4 members. That is it for the B. So we are now going to look at what? The C. So let's look at C. In C, they are saying that 1, 2, a set containing it is not a subset of B. That means we can list all the subsets of B except what? 1, 2. So as we already know that B of A, so we are now going to list all the members of B of A except the first one, if you can remember, except this one, this in a set that contains 1, 2. So here we will do our possible best to eliminate any set that constitutes 1, 2. So 2 is there, 3 is there, 4 is there, 5. Sorry, 5 is not there, right? So let me use my list. Let me use this board. I think it is better. Okay, so B should be what? All B of A except those that contains what? 1, 2 itself, except those that contains this. So it should not be. So as we already seen in this in A, so we will do our best to what? Eliminate all members that in a set that contains 1 and 2. So here we have the empty set, this, 1, 3. So now you will not hear 2. 1, 2 will not come together because 1, 2 is not what? A member. 1, 4, 2, 3, 2, 4, 2, 4, 1, 3, 4, 2, 3, 4, I think these are what the possible. So these are the possible sets, but it seems we didn't include 3 4. Okay, 3 4 is included. 3 4 should be included in the 2 2 sets. 2 3 2 2 4. There's no 3 4, so 3 4. So we have 1 2 3 4 5 6 7 8 9 10 11 12 members. So this set contains how many members? 12. Okay, so let's look at D. In D, B is not a subset of 1 2. It's just the opposite of 1 2 is not a subset of B. Here B is not a subset of 1 2. That means let's where is that? Okay, this one. Okay, so 1 2 is not a subset of B. B is not a subset of 1 2. So here B should not be the opposite of this. B is a subset of 1 2. So here B is not a subset of 1 2. If you still remember the set that has the set that is a subset of what? 1 2, which was the subsets were what? This the null set 1 2 and 1 2 itself. So the set that is not a subset of it, a set that is not a subset of this is what? The D. B is not a subset of this. So just make sure that all other sets are what? Stated, with the exception of what? All the other subsets are stated with the exception of what? These 4 elements. This, and that. So these 4 elements should not be included. So you can write this, you can list the members of this in the comment section. Okay, and if you have any problem, you can send me a message on the comment section and I will handle it for you. Okay, so we are now looking at the 10th question. A is equal to this. Are the following statements true or false? So this one is A is a member of A. This small a is not a member of A. A contains only what? One element, and that is the set containing what? A and B. The small a and B, but small a is not what? A member of A. A member of itself. Is A a member of itself? We say no. So the first one is false. The second one too is false. You might be asking, why is the second one? Why is B false? This set A is cannot be found in A itself. The set A, the members of A is only the small set here. How should I explain it to you? But we did it yesterday. I hope you understand. So this A is not a member of itself. Is the set containing A, B a member of A? We say true, that this one is true, because we can see the set, the whole set containing A and B, the members, the set containing the members A and B are found here. Is the only element in A, so this one is true. So it's false, and true. Please, if you need any clarification, leave a comment on the comment section, so that I will clarify your doubts for you. Okay, there are no elements in A. Is it true? Is it true that there are no elements in A? We say that it is false. This one is false because there is an element in what? There is an element in A, and the element is what? Is this one. So let me cancel here. So the element is what? The set containing A and B is the element. Okay, so we are done with 10. Let's look at 11. 11S, the empty set. The members of S are the empty set. So, and the what? And the set containing the empty set, and another set containing the empty set. And so we are just, we can see that this one is just talking about subsets. So the empty set, the set containing the empty self, and the set containing the empty set, and the set containing the empty set itself. So we can see that the empty set is A, then the set containing the empty set is B, then the set containing the 2 is what? C. This is what? S. So is the empty set a subset of it? Yes, so this is true. B, is it an element? Yes, we can see it as A. So you can see that represents our A here. So it's true, it's an element. The set containing the empty set, we represented it as our B, so it's a member. So it's true. The set containing the empty set, is it a subset of it? Is it a subset of it? Yes, it's a subset. So this, the set containing this, is a subset of what? S, because we can equally see it here. All the members here can be found in S because it contains only what? The empty set, and that is our A here. So this one, D, is also true. I leave the 2, E, and what? F for you to what? For you to interpret and determine whether it is what? True or false. Okay. So let's move to the what? Next question. Determine which of the following are true and which are false. 3 is a member of 1, 3, 5. This is true. We can see 3 in here. This is a member. No, the B is false. Why? Because we cannot see the set containing what? 3 here. There is no set containing 3 inside here. Before B can be true, there should be a set which contains this. If this was there, if it was this 3 and 5, we would have said that it is true, but this is not contained in the set, so it is what? False. So it is false. So this is true, this is false. So the second is false because we cannot see the whole of this. I explained it in the previous lesson, so let's just wrap up. Is this a subset of this? Yes, this is a subset of this. That means this set, the set which contains 3, is a subset of what? The set which contains 1, 3, and 5, because the member, the element in this set, if let's say A, the elements in A, which is 3, can also be found in what? 1, 3, 5, the set which contains it, which is the reason why this is what? C is true. So C is true. So let's look at this. 3, 5 is not a subset of 1, 3, 5. This is false, because if we list the subsets of 1, 3, 5, we have the empty set. Let me just list it first. Then 1, 3, 5 itself. 3, 5. This one. This 5. Then 3, 5 will also be a subset. You can see that 3, 5 is what? A subset. So they are saying that 3, 5 is not a subset, and 3, 5, we can clearly see that 3, 5 is what? A subset. So this is false. Okay, so this is false. What about the last one? 1, 3, 5 is a what? Subset of 1, 3, 5, and we all know that a set is a subset of itself. So E is true. Question 13. Determine whether each of the following statement is true or false. Justify your answer. So is the null set a subset of the null set? Is it a subset of the null set? I believe you can use the previous explanations to do this one. Okay, so let me just do some few. Let me do this, then this and that, ENF, so, and leave the rest to you to also complete. The null set is a subset of itself. It's true. The null set is a subset because it contains nothing, and the other one contains nothing. So then this is the null set. They are saying that is it a subset of this? Yes, it's a subset because both contains nothing. So they are subsets of each other. So this is a subset. This is a proper subset. Yes, it contains each other. This can be found in this, and this can also be found in this. Okay. Okay, so I said I will not do this, but I will do this, so you can do this. Okay, let me just do the C. Is the null set a member of the null set? Is this found here? Is the whole of this found inside here? You say that is no. The null set is not a member of the null set. It cannot be found inside. Okay, but here we can see clearly that it is inside. So this is false, whilst this is what? True. This is true. Okay. E 1, 2 is not a subset of this. 1, 2, 3. The members in this set can be found here. 1, 2 can be found here. That means that this is false because they say that it is not a subset, whilst it is a subset. 1, 2 is a subset of this, and it is true because the members 1, 2 or elements 1, 2 can be found inside the set 1, 2. So this set contains 1, 2, this. Okay. So let's look at, can we finish this page? Then we finish this page, then stop, so that we continue the rest in another tutorial. Okay, where are we? We are in the 14th question. Find 4 examples of a set X with the property that every element of X is a subset of X. You can give your examples. Find 4 examples. The empty set is a element. Sorry. You can give an example. Find 4 examples of a set X with the property that every element of X is a subset of X. Every element of X is a subset of X. So the empty set is equal to, let's say, X. So if X is equal to the empty set, that means the empty set is an element of what? X. If X is equal to what? The empty set. That means the empty set is what? A subset of X. I made a mistake. It's not a member, but rather what? A subset. So they say each member with the property that every element. So the element, the empty set, which is the empty set of X is a subset of X. So this is also a subset of X. This is one example. Example 1. So let me open my list. So let's say the example 2 will be what? X is equal to maybe a set which also contains the empty set, and a set that contains the empty set. So X is equal to a set containing what? The empty set. So here the members of this set will be what? The subsets of X. Members of it are also what? Subsets of X, because the empty set is a member, and the set containing it is what? Also is also containing a member of what? Is of the set containing this is also containing a member of what? X. So these are the subsets, and they are all members of what? X, and they are containing the members of X. Let's leave it that way. Okay, the other one is what? Let's think of power sets. So 3 power sets. So if X is equal to a maybe power set of, let's say, A, so that means the members of B are subsets of X. Sorry, the members of A. So let's say power set of what? The set A, and the set is let's say 1 and 2. So if the set A, let me do some cancelling. Okay, so just cancel it. So we are done with the 14th question. Let's look at the question 15. Find 3 sets U, V, W. So in this case, the sets we are going to find should satisfy the condition U is a subset of V, and V is a member of what? W. So assuming that u is equal to 2, then v should be equal to what? Set containing 2, and w is equal to the set containing 2 and what? 2 and v. So something like this. That's what they are just looking for. So find 3 sets. So this is good. Or if you let your u to be what? Empty set. Empty set. Empty set is what? A subset of v, which is what? Which is something like this. And then w will be comprised of the 2, which is this, and what? V. So w I'm talking about here will be equal to this, and then this, then v. So this so it's nothing. You can do it this way, and that is it. So thank you very much for taking your time and following me throughout this. So we've done another page, and we will be continuing from the 16th question in the next episode. See you. Thank you very much. But don't forget to subscribe to the Digitech, the home of advanced maths channel. Don't forget to subscribe. Thank you very much.